We're going to discuss conditional probabilities and when you should use a tree diagram for which scenarios. And some of you might prefer a table over a tree diagram. So we're going to talk about all that with this problem. Let's start with the problem. You are off to soccer and you want to be goalkeeper, but that depends on who is coached that day. These two bulleted points are what we call conditional probabilities. With Coach Sam, the probability of you being goalkeeper is 50%. That's not out of all the games played. That's only Coach Sam's games. That's what we call a conditional probability. You have a second conditional probability, and that is with Coach Alex. You have a 30% chance of playing goalkeeper. Now, Coach Sam and Coach Alex are not equally likely to be coaches. Sam is coached more often, about 6 out of every 10 games, or a probability of 0.6. This is not conditional. This is only one variable, and that is Sam coach, or who the coach is. This is two variables. These are like, when we did marginal and conditional in chapter 2. This is goalkeeper probability or percentage, but only when Sam's coaching. So you can see it's kind of a subcategory of this. This is goalkeeper probability, but only when Alex is the coach. So these are conditional. They're sub-probabilities within these other ones. When you are given this type of information, a tree diagram, in my opinion, is most useful. Some of you might like the chart. We're going to go ahead and do both. So the first branches of the tree represent your not conditional probabilities. This is out of all the games. Sam is a coach, 0.6, or probability of 0.6, and Alex would then be the coach, 0.4, or 40% of all games. Together, these two probabilities add to 100%. That will be true for every branch of the tree. So now, our next probability is off of this branch. Well, when Sam is the coach, what is the likelihood of you playing goalkeeper? That probability is told to me right here at 0.5. So this next branch is still off of, well, when Sam is the coach, what's the probability you're not goalkeeper? These two numbers here have to add to 100%. If 50% of Sam's games you're the goalkeeper, then 50% of Sam's games you're not the goalkeeper. Our next number, 0.3, is when Alex is the coach, what is the probability you are the goalkeeper? And that number is 0.3. And yet again, these two numbers need to add to 100%. If out of Alex's games, 30% you're the goalkeeper, then 70% you are not. Now, what do you do with these numbers in the tree diagram is you multiply them across. So I have 0.6 times 0.5, 0.6 times 0.5 again, 0.4 times 0.3, 0.4 times 0.7. These four numbers together add up to 100%. 30%, 60%, 72, 100. So this represents all of the games possibly played, and what these are the ands. This number is the probability of a game where Sam is the coach and you are the goalkeeper. This is the probability of a game where Sam is the coach and you are not the goalkeeper. This number is the probability of where Alex is the coach and you are the goalkeeper. And this is the probability where Alex is the coach and you are not the goalkeeper. So out of all the games possible, the games have to fall in one of these categories. So these are disjoint categories. Either Sam is the coach and you'll play goalkeeper, Sam is not the coach, Sam is the coach and you will not play goalkeeper, Alex is the coach and you will play goalkeeper, or Alex is the coach and you will not. You cannot, there is no game that can be in more than one of these categories. That's impossible. And that's what the tree diagram does, is it helps keep your percentages nice and clean and disjoint. Now, let's talk about how you would fill in the table. The table is going to be actually easier for me to fill in since I have done this. So I'm going to try to help you with filling in the table without you having already done the tree diagram. So you can then decide which do you like better, the tree or the table. There's really no reason to do both. You can if it helps you though. So the first probability that they told me that was not conditional, I'm going to start there, was that Sam is the coach 60% of the time. So here's Sam. But this is Sam goalkeeper, this is Sam no goalkeeper. This number has nothing to do with either one of these. This is like a total probability. So the 0.6 goes down here in the total. And when you have a probability table, the total here has to be 1. This has to represent all of the games. So that's where the 0.6 goes, and then by default, the 0.4. And those are those same two numbers that we have right here. They go under Sam's total and Alex's total. Now, the next number I was told to me is when Sam is the coach, the probability of goalkeeper is 50%. Biggest, most common mistake is to think that that 0.5 number goes right here with Sam and goalkeeper. And that's why one reason I don't like the table as much is because you just naturally want to put it there, and that is not where that number goes. In fact, it actually doesn't go anywhere in this table at all. But instead, we need to think about what that probability means. That probability means out of Sam's games, 50% of them you will be goalkeeper. So we have to take Sam's, it's sometimes easier if you think of these as numbers instead of probabilities. Instead of thinking it as 0.6, think of it as 60. 60 games Sam will coach. This does not mean that you're the goalkeeper for 50 of them. This means you're the goalkeeper for half of those 60. So half of 60 would be 30. But in probability, half of 60% is 30%. So what goes here is 0.3. And where that number comes from, that comes from the 50 of the 60. So, and what that number is this number right here, okay? It's after we multiplied. So in a table, it's all the way out here. In a tree, it's out here. In the table, you have to kind of just know that this 50% is of this 60% to get that 30%. Now, these probabilities need to add to 0.6, so this has to be 0.3. And now we're going to do the same thing for this 30%. Of Alex's games, 30% of them, you're the goalkeeper. So of Alex's 40%, 30% of the 40%, you're goalkeeper. And that turns out to be 0.12. And what that number is 30% of that 40% bottom. And yet again, this plus this needs to add to 0.4. That leaves me with 0.28. And now you should be able to see the four numbers on the insides of the table are the four numbers that are over here on the edge of my tree diagram. Okay? This 60 and this 40 are here. These numbers over here, this is the only reason that I might like for you to be able to do the tree diagram, is these numbers here are not in the table anywhere, but they might be useful numbers. And what they are, this 0.42 is the goalkeeper disregarding Sam or Alex coach. So it's this number plus this number. 0.3 plus 0.12. That's the two ways you could be goalkeeper, one with Sam, one with Alex. And the 0.58 are the other two added together. That's your no goalkeeper disregarding who is the coach. Now, once you have that all filled in, you can answer these questions. Most of this just you can pick right out of the table or right out of the tree diagram. What's the probability of a game having Sam as the coach and the you being goalkeeper? That's just 0.3. I can see it in the tree here, and I can see it in the table here. What's the probability of Alex being the coach and you being the goalkeeper? That's 0.12. I can see it in the tree here, and I can see it in the table here, Alex goalkeeper. What's the probability of goalkeeper? Now, this is just the probability you're the goalkeeper with disregard to who's the coach. That number is right here in the table. Now, if you did not make the table, you would have to find that number by thinking, well, where are the two places or the two scenarios where I could be the goalkeeper? Here or here. These are your two goalkeeper scenarios. So 0.3 plus 0.12. It's either you're here, or means add. All right, here's a conditional. Okay, we got to do a little bit more work for this. Find the probability that Sam's the coach, knowing you're the goalkeeper. So this knowing thing tells you that you need to look only at the two goalkeeper scenarios. So my denominator is 0.42. That's this number. That's the goalkeeper's scenarios added together. Now, out of those two, what's the probability that Sam's the coach? That's just this one. So your numerator is 0.3. On the table, you would zoom in on just this row, and you would say, okay, we're only looking at the goalkeeper games now. Sam was 0.3 out of a total of 0.42, excuse me. So that converts to about 0.71. All right, what's the probability that Alex is the coach, knowing you were a goalkeeper? So same thing, we're out of just the goalkeepers. Alex was the coach, 0.12. 0.29. Also to note, these two are complementary or add to 100% because out of all the goalkeeper games, either Sam or Alex was the coach. Those are the only choices. Is coach an independent of goalkeeper? So to answer that, you would just kind of say, well, let's find the probability of coach. And then let's ask ourselves, is that equal to probability of that person being a coach knowing you are a goalkeeper? And there's more than one way you could do this, but that's just what I went with first. So what's the probability Sam is your coach? That's 0.6. You can see it here in the table, here in the tree, here in the stem. Does that equal the probability that Sam is the coach knowing you are the goalkeeper? We've calculated that. That's 0.71. Those are not equal. So we would say that the coach and goalkeeper are not independent. All right, you need to do the back side of this worksheet. It's the same thing. I want you to do both the table and the tree diagram, and from there on out, you can then choose which method you like best. I will post those answers. Please email me if you have any questions.